So taking a look at a couple slightly more involved examples here in 6.2, we can certainly work with more than two fractions. Now, here is where it becomes a good idea when you're looking for the LCD to always look at your denominators and think about them factored first. Don't look at these three denominators and say, oh, well, they don't match, so they're all in my LCD. X plus 3, and that's as much as we can do to it. It is a factor. X can't be factored. It's a factor. But x squared plus 3x, that, with a GCF, factors to x times x plus 3. And so now as I ask, what do we need in this LCD? Well, clearly we need an x plus 3 from that denominator. We also need this specific factor of x from that denominator. But notice this denominator is already completely contained in that LCD. We do not need extra factors of this. It'd be like saying if you had a fraction of halves, a fraction of thirds, and a fraction of 6 there, right? You would need a 2 and a 3 in your LCD, but by doing a 2 and a 3, you already have a 6. So kind of the same thing, only with algebra. So that's our LCD. Now that means we need to write all three of these fractions with that as the LCD, or with that as the denominator, I should say. Okay. I'm going to stop drawing all the arcs because it gets very messy, but I'll keep asking the question. X plus 3 times what gave us this? Well, there's the missing factor of x. So we had 5x, and we now need to multiply it by an x. I'm going to write it that way for now just to show where this comes from. Okay, the next one. We had x, now we have this. Well, that's an x plus 3 factor. Well, we already had x plus 2 up there, and now we need to multiply that by x plus 3, the additional factor. And the last fraction had x and x plus 3 in it already, so that numerator actually will not change at all. Okay, so now, simplifying these things, we'll have 5x squared. In fact, let's go ahead, it doesn't matter. Let's go ahead and put this all over one fraction because they are now all matching denominators, but there's still some work to do. That'll be 5x squared. Here, we're going to have our 4 arcs to draw out to get us x squared plus 3x plus 2x plus 6, if you drew each of our 4 distribution arcs there, and then the minus 6 from that last fraction. All right, so that's all there to combine. Combining like terms, I get 6x squared from those x squared terms, plus 5x from those x terms, and 6 minus 6 actually goes away. Left over this. And so that's as much combining of like terms as you can do, but as we said before, to make sure a fraction's reduced, we do want to try to factor it to see if things cancel. And the one factoring we could do here is a GCF of x in both those terms. And with a GCF of x, we now see we have a common factor of x on numerator and denominator, which can both cancel, leaving us 6x plus 5 over x plus 3. And that would be the extent of the factoring, or the canceling rather. So that would be our final answer. Taking a look at one more. That denominator there can't be factored. X minus 1 can't be factored. But x squared minus 1 is a difference of squares that breaks down to x plus 1, x minus 1, meaning when we look for our LCD, we would need that factor and that factor, which would be both those factors. That's our LCD. So again, we're going to write each of these fractions with that as the LCD, as the denominator. And again, for this first fraction, we had the x plus 1, not the x minus 1, so we'll have 3x times the x minus 1. The next fraction was missing the x plus 1, so we'll have x times 4, or 4 times x plus 1. The last fraction had them both, so just bring down the numerator. And again, we now have all of them over the common denominator that we can combine, and we'll do our distributing. 3x squared minus 3x for those two. Now here, there's a couple ways you could do it. Don't lose the fact that this is a minus sign. I'm going to go ahead and just mention, distributing the 4 is not too tough here. That's going to be 4x plus 4. Make sure this minus sign gets distributed to those terms. You can either write it out in a line or kind of do it within this line of work. But minus in front of those terms makes that minus 4x and minus 4. Okay, don't miss that. Don't let that minus sign fool you. And then bring down the minus 6. Combining like terms, I'll have 3x squared minus 7x minus 10. Still over the x plus 1, x minus 1. And now, that right there is an x squared x no x. GCF isn't going to help us. 3 out front means we need to factor this or attempt to factor this with a bottoms-up approach. So, off to the side here. Negative 10 times 3 will be a negative 30. We need any factors of 30 that are also going to give us a negative 7, which right there we see it would be a positive 3 and a negative 10. So, taking that positive 3 and negative 10, x plus 3 and x minus 10, but then using the a to divide, giving us x plus 1 and x minus 10 thirds, and then the bottom coming up. So x plus 1 and 3x minus 10 is the factoring for this trinomial. So coming back over here, x plus 1 and 3x minus 10 over the x plus 1x minus 1 lets us see those factors cancel. So after all that work, we can simplify this down to the 3x minus 10 over the x minus 1 for our final answer. So we go from that complex looking one to what looks to be a very simple one, but this incorporates a trick we talked about earlier. Looking at those denominators, they don't match, they're not the same, but we don't want to necessarily think of them as completely separate different factors. We see both have 2's and t's, and specifically positive and negative 2, positive and negative t. We have those same terms, different signs scenario where the negative trick can help us. Doesn't really matter which one we do it to. If I look at this first denominator and thought, if I factor out a negative sign, negative 1, that'll be a negative 2 and a positive t. Now, we can say these things match, but let's point out what happens here. I'm going to write a line where it's 3 over the negative of, and I want to go ahead and rearrange that so it looks like t plus 2. Oops, sorry, that should be t minus 2. T minus 2. So now, I've done that negative trick. The denominators don't yet match, but we can get them to match very simply because a negative sign in front of my denominator would be the same as the negative sign in front of my fraction or even moved up to my numerator. So to do that and make that negative 3 over t minus 2. That's our negative trick being used to not have to find an LCD and take the time to rewrite these with a bigger denominator, and instead just use the negative trick to get them to match after you shift the negative out of there. Just don't forget to move it after you've done it, because then we've got those over t minus 2, and it's just a negative 3 plus a 1. So negative 2 over t minus 2. Do not cancel those, right? Those are not common factors. That's a factor, but that's just a term of our denominator. So that's our final answer there. All right, and then one last one here. Those denominators definitely do not match, but let's factor them first to see what they're made of. First denominator there, numbers that multiply to negative 4 and add to a positive 3 would be positive 4 and negative 1. Second denominator, easy case, numbers that multiply to a positive 4 and add to a positive 7 would be positive 3 and positive 4. And so, when looking for the LCD here, we'll notice we only need the one copy of a plus 4, since it's once here and once here. We'll also need the a minus 1, and we'll also need the a plus 3. So our LCD here, kind of long, a plus 4, a minus 1, and a plus 3. But now, same idea. This denominator had those two factors. It was only missing a plus 3. So I'll take the negative a times that missing a plus 3. This denominator had the plus 3 and the plus 4. It was only missing the a minus 1. So I'll take 4a times a minus 1. So now we've got these able to be combined into a single fraction with that as our denominator. Up here we'll have negative a squared minus 3a as I distribute that. Again, with a minus sign, either do it in 2 lines or be careful. I'll go ahead and just do a quick distribution here and see that's 4a squared minus 4a, but then minus all of that will be minus 4a squared and plus 4a. Now, from there, we can combine like terms and get negative 5a squared plus an a up top. With that same denominator down below. And notice we do have an a in common here, a GCF of a. In fact, we could even factor out the negative because we don't like leading terms being negative. So if I said the GCF of negative a comes out, that turns into 5a plus 1 left over. That's as much factoring as we can do. And with that factoring, notice we do not have any factors that cancel. So that would be our final form. We always want a factor to look for any factors that do cancel.